Hello and welcome to another physics lesson. In this video, we are going to talk about the net force and Newton's second law. Recall a while ago, free body diagrams were introduced to illustrate how forces were acting on an object, whether it was a single force or multiple forces. With so many forces, how do you determine the motion of the object? What needs to be found is something called the net force, a single force equating to the total of multiple forces combined. Be aware that if there is only one force acting on an object, that force is the net force. The net force controls the motion of the object, but what does that mean exactly? It means the net force exerts a push or pull, causing an object to speed up, slow down, or change direction. With that being said, there is a relationship between acceleration and net force, which leads us to Newton's second law. Newton's second law says the acceleration of an object is directly proportional to the net force acting on the object and inversely proportional to the object's mass. There is an equation that comes with the law. Acceleration equals to the net force divided by the mass. Let's try an example using Newton's second law. A worker pushes an 8 kilogram box with a force of 31 newtons to the right. The force of friction is 9 newtons. What is the net force? And then second, what is the acceleration? First, start the free body diagram by drawing a box to represent the object being acted on, which is also a box. Next, identify and add all the force vectors. We can add the force of the worker by drawing it to the right. Next, the force of friction can be added by drawing it to the left. Force of gravity and normal force are certainly in the problem, but it's not going to affect the net force as those two forces will cancel each other out. To calculate the net force, we can look at these two forces, force of the worker and force of friction, and say they are against each other. If that's the case, to find the net force, it would be the force of the worker minus friction force. This gives a force of 22 newtons to the right. To get the acceleration, the net force of 22 newtons is taken and divided by the mass of 8.0 kilograms. And the acceleration is 2.8 meters per second squared. This concludes this problem and this video. The next video will conclude a slightly longer problem using Newton's second law. Hope you found it helpful, and thanks for watching.